Okay, like I was telling you guys, welcome back from the break. It's Unit 3. Okay, we're jumping into Unit 3. Today's notes are going to be long. They're going to be long. I hate to tell you that, but just like every other unit when we went into graphing, there was a lot of stuff that I need to cover. There's some rules that I need to cover. I want to make sure I cover all the important bases. Now, today we're going to talk about multiplying. Okay, the more attention you pay to this, the easier it's going to be. Okay, if you kind of zone out on this, if you zone out, you're going to be completely lost. Okay, I'm going to try to give you guys breaks where you can like stand up and stretch and do whatever you need to do. Yesterday during third period, literally these notes took a full hour. Okay, I don't like talking that long. Hopefully we can get through it a little bit quicker than that today. Okay, cool. All right, here we go. Exponents. Let me get my clicker. I did buy a new clicker over the break. I know you guys are excited about my clicker. Okay, see, brand new one. The other one was breaking. Do you guys remember that? Like it was snapping. So I went and bought another one because this thing was breaking. All right, here we go. Exponents. A couple things. Somewhere on your note page, I want you to write that down. 4x squared, please. And we're going to identify the parts of a exponent really, really quick. What's the 2? You guys remember? What's the 2 called?
Squared.
Well, but what is it? That's your exponent. Okay, we obviously know that. Okay, that's kind of what we're talking about. We know what exponents are. You understand what an exponent means, yes? Okay, we'll talk about that in a minute. What is the x? It's a variable, 100%. But if it has the exponent on it, guys, it is your base. Okay, that is your base. Okay, please label that. Please write that down. Make sure you know this. Because some of these words, I'm going to use these words quite a bit. I'm going to say base. I'm going to say exponent. What about that 4 in the front? People have gotten this one right, so I want to see if we remember. What's the number? What's the term for number in front? Do what? Okay, this is a coefficient. You guys remember that now? Okay, coefficient. Okay, now, what does 5 squared mean? What does 5 squared mean? Let's talk about it. 5 times 5, yes? Everybody understand that? 5 times 5, which is what? 25. We know that. So we know that 5 squared is 25. I want you to understand what exponents mean. I can't take that for granted that you guys just fully understand that, okay? What that does is that tells you how many times you're going to multiply the base, okay? Now, one of the funky rules about math, okay? And I need to show you this. I'm going to show you this off the bat. Do you guys have your calculator? Okay, go ahead and open your calculator really, really quick. I want you to do this. We know that 5 squared is 25, right? We know if you put this in, if you went 5 and then you hit this button on your calculator, which is above the division sign, it's right above the division sign, there's a little button. Okay, it should tell you 25, yes? Now, what is negative 5 squared? What would you think? You would think positive because a negative times a negative, right? Would you agree with that? Okay, yes? So why does your calculator tell you negative 25? Because isn't a negative times a negative a what? I've been telling you this for a while. It's a positive. So why would negative 5 squared be a negative? Anybody know? No, they don't flip. Check this out. I want you to put this in your calculator now. Put a parentheses. And do it like that. Now do it. Tell me what you get. Positive 25. So this is one of those little funky math rules that we need to cover, okay? When you're talking about exponents, exponents only go to what it is exactly next to, okay? So in this case, my base is the 5, yes? The negative just becomes part of the answer. So we squared the 5. What's 5 squared again? It's 25. So what do I do with that negative? Put it on the front. We didn't square the negative. But if we put it in parentheses, we square everything on the inside, including the negative. Does that make sense? Please be aware of that. You are going to make that mistake. Okay, so a lot of you guys are going to make that mistake. So please, 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 please be aware of it. Okay, if you come to me and you're like, man, I'm Coach Boy, I don't know why I missed that. I might just say the word parentheses. You got to use parentheses. Okay? All right, here we go. We're good there. Let's talk about this. Identify the base. We're going to identify the exponent. I'm going to try to go pretty quick. All right, here we go. First one, 5 to the third power. What's the base? What's the exponent? Perfect. So here's how I want to write this. I'm going to go B. I'm just going to put B. The B is 5. The exponent is 3. So what does 5 to the third power mean, guys? 5 times 5 times 5. Good. Let's talk about B. What's the base?
5.
Nope.
Oh, there. No.
What? No, what's the base? What's the base? What's being multiplied?
9.
-9. Base is -9. What's my exponent?
5.
5. So how would I write this, guys? -9 times.
-9.
Good. All right. Let's see if you can figure out C. Go. Just really, really quick. I'm going to give you maybe 15 seconds to kind of look at it. See if you can figure out the base, figure out the exponent. All right. What's the base on C? No. Parentheses. What's the base? 11. So my base is 11. My exponent is what? 3. Now here's how. Now what's being multiplied 3 times? What number is it? 11 is being multiplied 3 times. So we got 11 times 11. Oh, not dot. 11 times 11. By the way, get into using dots for parentheses. Don't use X. Why not? What is X in algebra?
Like
it's a variable. Get used to using dots or stars or whatever else, okay? Or parentheses, okay? Now, what's missing? What about the negative? All you got to do is take this negative, just put it down there on the front. Just put it on the front, guys. It just becomes part of the answer. Does everybody understand that point with the negative now? Okay. All right. What's my base is on D? 4 and 3. Good. What are my exponents? 5 and 6. And how do I write this in expanded form? Expanded form means I just take a smallet and I just think about it. I just stretch it out. That's what expanded is. Agreed? Expanded is just stretched out. So what do? How many times do I multiply 4? 4, 4, 4, 4, 4. How many times do I write 3? 3, 3, 3, 3, 3, 3, 6, 7. Expanded form. That's why exponents come in handy. Is everybody cool so far? Everybody understand? Obviously, it's not going to be that easy. I'm just kind of giving you the baseline. What is it? The base information. Yes? Everybody's good so far? All right, cool. Let's move on. Hey, by the way, you're going to have to participate with me. Like, I know Mia's done a good job, but you've got to talk to me. The more you nod and tell me, yep, I've got it, the faster I can go because I feel like you're understanding. Yeah, everybody good? Please let me know that. All right, here we go. 4 squared, x squared. So here we go. We're going to go from exponential form or exponent form to expanded. All right, so here we go. What do? What does 4 squared mean?
4 times 4.
4 times 4. And what does x squared mean? X times x. Good. Now what's 4 times 4? 16. What's x times x? Nope, not 2x. X squared again. Basically, I just put it back together. You don't necessarily have to do that. It's just notes. I'm just explaining to you what it's doing, okay? We can expand the 4 times 4. Now, most of you guys will not have any problems with doing this. You should be able to do a lot of these in your head. You're like, I know that 4 squared is 16. I get that. I want you to understand the expanded form because some of these problems are going to get a little more complicated, and it's a whole lot easier when you actually just write them out, okay? Don't try to do this stuff in your head because the biggest mistake that people make, like I said, I've been doing this for a long time. The mistakes that people are making is not that they don't know how to do the math. It's just that they try to do too much in their head and they get stuck. Okay, so please expand these things out and write them out. It takes what, an extra 10 seconds to maybe write it out? Who cares? So write it out and make sure that you understand what it's asking you. Okay, I'm going to show you an example of that here in a little while. Okay, so isn't this one kind of the same thing? It's 4x twice. 4x times 4x, yes? Now, it's the same thing, guys. When you have these numbers on the front, when you have the coefficients, the 4 times the 4, you just multiply those together. They don't fall under exponent rules because they're not exponents. They're just numbers, 4 times 4. Okay, they don't follow. We're going to get into the rules here in a minute. What's 4 times 4? 16. What's x times x? X what? Squared again. X squared again. All right, so let's do 2 more. Now I'm going to erase these. Negative 4x squared, so now it's going to be negative 4, right, times negative 4. What's negative 4 times negative 4? Positive 16, so it should look like this. Negative 4x times negative 4x. Yes, because we got 2 of them. What's negative 4 and negative 4? Positive 16. 16 what? X squared. Now, another way that you can look at it is distributing the negative, or it's distributing the square. I could distribute that exponent to everything inside. Okay, that's the way I always did it. But like I said, I'm giving you the base work now. After I give you the base work, however you solve it is how you solve it. Okay. Have I ever said to you, you have to do it my way or it's going to be wrong? I've never said that. Okay. As long as you're getting the right answer, I don't care if you look at it as distributing or you spread it out or you just kind of, as long as you're getting the right answer, I really don't care. I don't care how you load the dishwasher, just get it loaded. Okay. Get everything in there so I can get it clean. I don't care the process you use, just put it in there. All right. What's the last one? What's getting multiplied twice? 4 what? 4x and 4x, right? Good, you guys are understanding. So what's 4 times 4? 16 what? X squared. What am I missing? The negative comes down. It's just part of the answer, so it's negative 16x squared. Okay, you guys see the difference there? Okay, is everybody good? All right, let's start talking about rules. Everybody likes rules. Actually, we'll get to that in a minute. I'm not going to spend a whole lot of time on this. A, B, C, and D, I'm going to give you guys a minute, and I want you guys to what I want you to do is write these in exponent form. So 8 times 8 times 8 times 8 is what, guys? 8 to the what? 8 to the power of 4. Okay, I want you to do A, B, C, and D. Ready? Go. I accidentally stopped the video. I guess we're going to do this in 2 videos. That's all right. It works. All right, so I'm going to skip letter B for a minute. Let's go to C. What'd you get? What's being repeated? Negative M is being repeated. So I'm going to put it in what? Parentheses, because the negative is included. The negative is included, yes? So negative M, how many? 4. And then how many P's?
2.
P, 2. You didn't have to put the P in parentheses because it's positive, but I just did anyway. Okay, everybody good? If you put P without the parentheses, you're still okay. How many of you did that? A couple of you. Good. See? Doesn't matter. All right, what about D? How many 7s? This one I'm going to do without parentheses. Do you see any negatives? So I'm not going to use parentheses. Could I use negative, or could I use a parentheses? Yeah, absolutely. Okay, 7 to the 3rd power. What about R? Okay, 1, 2, 3. What's next? 2 R's. How many Z's? 3. I could, again, that's right, or I could do this. Everybody, I can do that very easily. Okay, same. It's the same thing. All right, here we go. Letter B. What'd you get? How'd you write it? That's it? Hold on. Is the negative being repeated? So, okay, so you did this? Okay, either one of those would work. Okay, if you put negative C to the 5th power without the parentheses, that still is the same thing. As long as it shows that the C is being repeated 5 times. If I do this, doesn't that show that the C is being repeated 5 times? Yeah. If I do this, is the C being repeated 5 times? Same thing. Okay. As long as the negative is not in the parentheses, you're still okay. Okay. Everybody good? Good. Now, here we go. Let's go to work. 2 to the 4th times 2 to the 3rd. Now we're going to get into the rules. And I want you to pay attention to what we're doing because this is where it starts getting very, very important. All right, here we go. 2 to the 4th times 2 to the 3rd. What does 2 to the 4th mean? Now, this means 2 times 2 times 2 times 2. Yes? What does 2 to the 3rd mean? 2 times 2 times 2. Yes? Now, forget about the problem. Look at what I just wrote down. What did I write? What do you notice? Same number. How many times? How many are there? If I just gave you that and I said write that in exponent form, how would you write it? 2 to the what? 2 to the power of 7. What do you notice? Look. Go ahead and say it. Say it. All I did was I added the exponents. I went 4 plus 3. You guys with me on this? Okay, so do me a favor. A, B, C, D, and E. I want you guys to go ahead and do that and see if you can simplify it. This class, I don't think I need to explain a whole lot, okay? C is a little trickier, okay? But just pay attention to what you're doing. Fair? I'll give you guys about a minute. Go. All right, what'd you get for B, guys? Negative 3 to the what? Fifth. Yeah, because there's 3 of them. There's 2 of them. You just add them together. Do I need to expand that out? Does everybody understand that? Yes, everybody understands? Is there a no? Does anybody not understand what I just did? Because it's early. I know it's only like 2 examples in. I want to make sure we got it. Okay, let's go to C. What is this? A to the what? Oh. Hold on. Oh, I see people nodding like, yeah, we got it right. Okay, listen to me. You've been doing this since like 2nd grade and you didn't even realize it. Okay, what is 5 times 5 again? Let's go back to this problem. What is that? 25. Well, let's write it as an exponent. What is 5 times 5? What is it? 5 what? 5 what? Isn't that 5 squared? Hold on. If you don't see an exponent, isn't it ones? What? Hold on. What's 1 plus 1? If you don't see an exponent, it's a 1. Okay. If you do not see an exponent, it's always going to be a 1. Okay. If you see, you may know what anything to the 0 power is. It's 1. I'll explain to you in a minute. Okay. There is a pattern. Okay. And I'll show you here in a minute why it's 1. Okay. There is a reason. Everybody understand? Just trust me on this. I will show it to you. But 0 power is what? 1. Just keep that in mind because you are going to see that. All right. Here we go. D, or what is M? How many M's? I got M2, M3. M what? M5. Done. Now watch, see how I'm doing this? What did I do? Well, I added them up, and then what did I do with the M's? I crossed them off because they're done. I've combined them. Now what's left? P what? P what? P3, P2, and P1. Okay, if there's no number, it's a 1. Yes? It's no number, it's a 1. It's kind of like anything else. Okay, what about E? 9 to the 5th power. I got 3 and 2. And then I've got Y to the, I got 2 and 5. 7. Okay, is there, even if it's a negative, just add them together. Okay, you guys, if you see a negative exponent, now we'll get to where when you have negative exponents and we tell you they have to be positive, you got to, there's a lot of different rules. Okay, we'll get to that later. Okay, but if you see a problem today and it just says add them together, just add them. If it's a negative, who cares? Okay, later on I will show you how to get rid of a negative exponent. Okay, all right. So what did you notice about the relationship between the original? What did we do? Okay, what did we do, guys? What did you tell me to do? When we have a common base, what did we do? Okay. Okay, here's your, when you multiply with a common base, when you multiply with a common base, you add the exponents. This is very important. You add the exponents. When you multiply with a common base, you have to add the exponents. That is rule number 1 that I want you to learn today. When you multiply with a common base, what do? Add the exponents together. Okay, your official Algebra 1, like, super smarty rule is written like this. X to the A times X to the B. Okay, common base, right? This is the official rule, by the way. What's my base? What's the matching base? What's the base? What's the big one? X. What are my 2 exponents? I would just add them together, A plus B. Okay, that's the official rule for Algebra 1 for the exponents. Everybody good? Okay. All right, are we good? Are we good on the front? We're going to flip over to the back now. Now on the back, it's going to get a little bit more complicated because now we're going to get some powers of powers. Okay, exponents with exponents on top of that. Okay, so then it gets a little more complex. Everybody good so far? Nod. Tell me that you're with me. I know it's day 1 after Christmas break. I get it. You guys are tired. Okay, lots of video games or whatever else, SpongeBob episodes or whatever you guys watch these days. Okay. All right, here we go. Exploring power over power. Use our previous definition of repeated multiplication to expand the expressions and simplify. In other words, just expand it out and simplify it. Yes? All right, here we go. We got a to the third or 8 to the second to the 3rd power. Okay, let me stop. I see immediately some of your eyes went. Yeah, it's really funny, actually. Okay, start on the inside. What do you have? 8 to the what? You have 8 squared. Hold on. You have 8 squared. How many times do I want to repeat 8 squared? 3 times. Everybody catch it? Hold on, catch this. I have 8 squared, and I want to repeat that 3 different times. Does that make you like, okay, I kind of get that. So what I'm going to do is I'm going to take that 8 squared and I'm going to do this. I'm going to go 8 squared times 8 squared times 8 squared. Now it's 8 squared to the third power. Okay, let me stop. I'm going to slow down just for a second. Is everybody like, okay, I get that. Everybody's good? 8 squared 3 times. Now, what does 8, I'm going to expand this even further. I'm going to take my balloon and stretch it out a little further. What does 8 squared mean? 8 times 8, right? So I'm going to expand it even further. So each one of these, I'm going to go 8 times 8 times, and then I'm going to do it again. 8 times 8, and then I'm going to do times 8 times 8. Yes? How many times do you see 8 times 8? How many 8s do you see? 6 of them. My final answer is 8 to the 6th power. Oh my gosh, she caught it. What'd you just say? You just multiply the exponents together. 3 and a 2. I know that. I could have told you that to start with, yes? But then I want you to understand the why behind it. Haven't I always been that way? I want you to understand the why. I want you to understand the concept behind what we're doing. If you find the shortcut and say, you know what, all we got to do is multiply 2 times 3, sweet, multiply it. But you need to understand a power of a power we're going to multiply, okay? But that's why. All right, here we go. So what's the next one going to be? What repeats? Nope. 5 to the 4th power, how many times? Now I'm not gonna expand it all the way out. What do you do when you multiply with a common base? What's the rule we just learned? When you multiply with a common base, what do we do with the exponents? Nope. Add them together. So what's 5? What's 4 plus 4? 8. So basically I can look at it like that, or I can expand it out and add them together. It's the same thing. Yes? Okay. Now we can do the, oh, am I done with that one? I gotta have the negative on the front. Sorry, there it is. I forgot the negative. Ah, okay. I went to college with a guy up in Durant, and he was from Ireland, and every time he would go, he would go, ar. I drive an infinity, piece of crap. Okay, all right, that's what he would actually say. It was really funny. All right, what'd you get for C? J to the what, guys? No. J to the power of what? 12. Now, D is going to be a little bit more complex. Would you agree? Hold on. This is one of those examples. I told you you're going to come into one of these examples here in a minute that you might look at it and say, it's a little much. Agreed? So what can I do? Hold on. I'm going to rewrite it up here, by the way. Negative 2 p to the third to the second power. Okay, this is where we're at. This one right here. If you're confused, what can I do? Say it. Not add. Write it out. Expand it out. Okay? So go ahead and do me a favor. Take this, write it twice. Take it, write it twice. Negative 2p to the third power, negative 2p to the third power. Because it's squared. Would you agree? There's 2 of them. It says negative 2p to the third power squared. So I'm going to take it, I'm going to write it twice. Is it hot in here to anybody else? Like kind of muggy, like it's perfect. Man, I'm sweating. All right, here we go. So I've got negative 2 p to the third power, negative 2 p to the third power. Isn't that the definition of negative 2 p to the third power squared? Okay, I see a lot of people nodding. Is everybody with me so far? This is why I say expand it out if you need to. Okay, so here we go. Coefficients. What is negative 2 times negative 2? Positive 4. I'm going to cross them off because I'm done with them. Now, what's next? What's p to the third times p to the third? When you multiply with a common base, you add the exponents. What's 3 plus 3? We're done. It's a whole lot easier when you expand them out sometimes. I see a lot of people nodding. You guys see that? Don't be scared to like expand it and say, oh, okay. Now, I could also, if you're getting good at this, I could distribute. The 2 goes to everything inside. Yes? Two negatives become a what? Positive, so I don't need to worry about it. What's 2 squared? 4. Power of a power, what do I do? Nope, you multiply power of a power. Same answer. The 2 gets distributed to everything on the inside of the parentheses. That's another way to look at it. I see more people nodding. Everybody good? Okay. All right, let's go to this last. Oh, here's the rule. What relationship did you notice? What do we do with the power of a power? Power of a power. Multiply. So here's your official rule. X to the A to the B. What do I do with those 2? No, multiply them. Power of a power, I multiply. A, B. I got to multiply them together. Or you could put A times B if you would like to. Everybody good? All right. The rest of this worksheet, okay, is just a little bit of a practice problem, okay? I'm going to give you guys about 2 or 3 minutes to work with your partner next to you, and I want you to see if you can work through this problem. Skip the ones that you don't know how to do, because I'm going to go through every single one of them. And then after we're done with that, we're going to take a break. Fair? Finish the problems. Cool? Go. While you guys are working on this, I need to add one more thing. Not really add it, but I'm going to give you another way to look at it. When they're separated, repeat after me. If they're separated, you add.
If they're separated, you add.
When they're squeezed together, you multiply.
When they're squeezed together, you multiply.
Kind of like power of power. You see how that's squeezed together? I would multiply those together. These are separated. I'm going to add those together. Okay? You guys with me on that? A power of a power. The powers are like basically squeezed together. That's a key that I'm going to multiply them together. Everybody with me? Okay, go. All right, here we go. Let's do the first one. 6 to the 4th times 6 to the 3rd. Guys, what'd you get? 6 6 to the what? I'm fighting not doing it. Okay. What'd you get for B? X to the 15th. Good. X to the power of 15. You add them together. Okay. What'd you get for C? W to the 15th power. Okay. You multiply those because it's a power of a power. Okay. So we multiply it together. D? No answers? We want to come back to that one? Let's come back to it. Haven't got there yet? Oh, were you going back and forth this way? All right, cool. Let's do F. What'd you get? M to the what? M to the power of 8. Remember, that's a 1. So we just added 5 plus 2 plus 1. Not a big deal. Okay? All right. G. That 4th power distributes to everything in there. So the X becomes a what? What does the Y become? X to the 4th and Y to the 4th. Because think about it. If I stretch it out, XY, 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 XY. Yes? How many X's? 4. How many Y's? 4. Make sense? Okay, or you can just distribute it. All right, here we go. H. This one, a lot of people way overthought the other day. What are my coefficients?
3 and 7.
What's 3 times 7? 21. Then I got D2, D5. D7. Done. Please don't overthink that. How many of you overthought that one? Yep. It's common. Because I told you that people overthought it, so I'm not surprised by that. All right. Should we go back to D? Let's get to D. I'm going to write it up here. 2 because I'm short. Well, the board is short. All right. The 5 distributes to everything inside, yes? Now, we know that the A is going to be what power? What's the B going to be? They're both going to be A to the 5th, B to the 5th, yes? Is everybody good with that? Okay, what about... You guys have a calculator? Yeah. What is 2 to the 5th power? Calculator. Just check it.
32.
Is it? 4, 4. Yep, it's 32. Is that what you got? We simplified it. Wake up, wake up, wake up. Focus for me. Hey, we're almost done. This is the last part. Okay. I know it's first. I told you these are going to be long today, didn't I? I told you. All right. Let's go to I. -5. A squared. B all to the third power. Yes? All right. What is negative? Let's do this. What is -5 to the third power? Calculator. -125. There's 3 of them, which means it's going to stay as a negative. Think about it. Negative, positive, negative, positive, negative. Because when you multiply a negative times a negative, what do you get? And then it goes back to a negative. Then it goes back. So if it's an even exponent, it's going to stay as an. If it's an even, it's going to be positive. If it's odd, it's going to be negative. If there's a negative involved. Okay. All right. What's 2 times 3? A to the what? B to the what? Third. We're done. Just distributed it, everything in there. If you need to expand it and write it out, please do that. Don't try to do this in your head. Okay. All right. One more. Did anybody take a stab at E? You did? What'd you get? -8H2. Oh, what? Hold on. Negative what? 8. Close. Hold on. Okay, I'm gonna give you guys a second to work on this. I'm not gonna pause the video. Okay, but start with your coefficients. Start with the coefficients and then go to the H's. Start with the coefficients first. Nobody's telling me they're confused, so that's why I'm just kind of on cruise control. If you're confused, you need to let me know. Grand Hotel. When you have an answer, raise your hand. Coffee. Yes? No? How many of you gave it up? A couple of you? All right. What are the coefficients?
8, 5, 2.
There's a way to do this in your head, by the way. I'm going to start over here. What's 5 times 2? What's 10 times -8? -80. I just multiplied those 3 numbers together. If you went left to right, you would get -8 times 5, which is -40. And then you multiply it times 2, you get -80. So it doesn't really matter which direction you go. How many of you are like, oh man, I can't believe I missed that? Yes? Is everybody all right so far? Just take the coefficients and just multiply them together. They will be just fine. Okay, yes?
Is it -80 to the power of
Nope.
-80H?
H to the power of what?
15.
16.
Oh, you have that one.
How many of you, anybody forget the 1? Yep, a lot of people. You notice I'm not surprised when you guys do that? I see this every year. Okay, so it doesn't really surprise me. 2, 1, 3, 10. When you multiply with a common base, what do you do with the exponents? You add them. So we just talked about that, guys. Listen, summarize. When you multiply with a common base, you add the exponents. Yes? When you multiply a power of a power, what do you do with the exponents? Multiply them together. Okay, you need to remember the rules. Don't just blow this off, because when you guys come back on, was it Friday now? What's today, Wednesday? Yeah, when you guys come back on Friday, we're going to do division. Okay, now let me show you 0 power really, really quick. Okay, this is not hard. Okay, but I do want you to understand the why behind it. I probably don't have to explain it today, but I'm just going to. Okay, what did I tell you that 0 power was? Okay, so 2 to the 0 power, I just told you was 1. Yes? So what would 2 to the first power be, which is basically just what number? 2. Okay, what's 2 to the second power? No, what's 2 times 2? 4. What's 2 to the third power? Don't say 8, or don't say 6. It's 8. Yes? Now, because if you use your calculator, 2 times 2 times 2. Yes? Okay. Now, let's go backwards. Look at my exponents. 3, 2, 1, 0. What's the next one down? -1. Now, if you guys put 2 to the negative first power in your calculator, it's going to say 0.5. Okay? It's actually, as a fraction, it's 1/2, okay? We'll get to negative exponents eventually, okay? 2 to the negative second power it's basically the same thing, just flipped over. You guys see that? 2, 1/2. What's negative second power would be 1 what? 1/4. What would 2 to the negative third power be? 1/8. Now, let me show you something really, really quick. What did I tell you 0 power was? 1. Do you guys see a pattern going this direction? What's the pattern? What are they doing to every one of these? Say it. They're dividing by 2. So if I go 8 divided by 2 and then 4 divided by 2, but here's the key. What is 2 divided by 2? 1. And then what is 1 divided by 2? 1/2. If you put a 0 there, it kills the pattern. It absolutely kills the pattern, because think about it. If I put a 0 here, it doesn't fit in the pattern, because 2 divided by 2 is not 0. You basically just kill. If we go the other direction, if you're multiplying by 2, yes, go the other way. Times 2, times 2, times 2. What is 0 times 2? 0, not 2. Okay, so it has to be 1. It has to be, just for that reason. I see a lot of nodding. Like, you understand that now? So it doesn't matter what it is. It could be a big, huge 3x squared y to the third, z over 5x to the 0 power. If the 0 power is on the outside, the entire thing is 1. The entire thing is 1. Okay, just so that you're aware of that. Cool? Good job today. I know that's really, really long. I'm going to give you guys some break time. Cool? All right, good job today, guys.